Okay, are we ready to get started? Okay, simulation. Wow, is that where we're at? Where am I going to start this at? Like here. All right. No. This would be better. Like here. What you're looking at right here is I posted this, and there are 3 simulation equations that you got to get yourself familiar with. And I'm kind of trying to put Chapter 12 in a nutshell and helping you kind of quickly get to where you need to be for the final exam. And where you need to be is when you read a question related to simulation, it's all about saying, okay, which one of these 3 formulas should I be using? Being able to identify which one of these 3 is the key. I'll try to add in, I know I'm going kind of quick because we're kind of way behind where I thought we'd be today, but maybe on Wednesday I'll add a little more real-life examples because I've used simulation several times in my short career that I had. It's a really great tool, and you probably won't use it till you're like 10 to 15 years out of college, but then all of a sudden you've got a seat at the table, and this simulation is the big deal to get everybody to get on the same page because you are going to be part of the decision, should we risk the company's money and do this or that? And when you're part of the decision to make that decision, you want to make sure that you have the low risk. And this really helps you identify how much risk you're taking. It's called simulation. Here are the 3. Let me start with uniform, right here in the middle. The description of the data will either say it's uniformly distributed, or it will say, and every possibility has the same probability. An example would be a die. It has 6 sides on it, 1 through 6. And whenever I roll it, whenever any of us roll it, every side of it has the exact same probability. So, it's called uniform. Again, look for the words, and the mechanic for this airline usually spends 2 to 4 hours on the plane after each flight, or after a day of flights or something. And the amount of time is uniformly distributed between those 2 hours, 4 and 2. Get it? That means however much time that mechanic's spending between 2 and 4 hours, every single possible amount of time has the same probability. And in real life, this comes up where everybody goes, oh, I know it'll be between 2 and 4 hours, but I don't know if it'll be 2 or 4, that you have exactly the same chance of being, and everything in between also. That's uniform. I won't try to trick you. If you look at the back of the chapter, most of the problems that describe uniform data, it uses the word, and it's uniformly distributed. So, if this is on the final, I probably will include the word uniform. And if I do, you're going to want to know a formula where in Excel you put equals the cell location where the smallest of the range is, and in the mechanic I said 2 to 4 hours, so it would be wherever the 2 is at the top of your Excel spreadsheet. Like up here, there it is where the 80 is and the 100, there's the smallest and there's the largest. I can tell that's a uniform because of the word smallest and largest up there, and if I made this spreadsheet really good, I would have put the word uniform above it. But it's the smallest number or largest. It's actually, there's 3 different ways to solve this. Or largest, plus, in this case minus. You're telling Excel to pick a random number between 0 and 1, and we've experienced this already. R-A-N-D, parentheses, no space in that at all. Not even between those parentheses. No spaces. Times, you've got to use that symbol for multiply, or Excel doesn't know what you mean when you put something next to something like algebra. You've got to use that symbol. Parentheses, the largest number, or the cell location for the largest, minus the cell location for the smallest. So in this example, it will say 100 minus 80, which is 20, times a random 0.5. Excel comes up with 0.5. So now 0.5 times the range is, what was that, 20 is 10. Now add 10 to the smallest, so 10 plus 80. For this trial, the random number is 90. Now if Excel would have picked 0.25, it would have been 100 minus 80, that 20 times the 0.25, which is a quarter of it. What is that, 5? add it to the smallest. So 80 plus 5, now we're using 85. You can do the same thing with the largest. It's just a different way of writing it. It does the exact same thing. Oh, I'm sorry. Yeah, but you're subtracting here instead of adding. And then I want to show you one other way, like one more way. And a lot of people like this one a lot, and this is the cell location where the largest is. Now, this is the key to this, comma, not colon. Cell location where the smallest is. 3 different ways you can take the data and let Excel use randomness to come up with that information. Somewhere between 80 and 100, and da-da-da. And look what's happening here. 94.88, 94.39, 95 point, somewhere between 80 and 100. 80.35, 83.3. All of these numbers are between 80 and 100, and every number between them has an equal chance of coming up using any of these 3 formulas. And in the problem it said this data is uniformly distributed, or says something about it having the exact same probability, like a dot. Next. Okay. Saving that one. We're going to this one right here. Normal data. I'm sorry, I forgot all about it.
Is the second word random? Like the SM?
This is R-A-N-D,
Okay.
and then parentheses, parentheses.
I just want to make sure.
Yep. Just a little sloppy. All right. Next, normal data. How do you recognize that normal data is being described to you? It will say, and the mean and standard deviations are. It will be the only data that has the standard deviation in its description. It's the only one. And if you see the standard deviation as part of the description, you've got to know you're using this Excel command. Normal INV. Right? Now, the reason I'm really making sure you get these is they're not on the PowerPoint. They're in the book. The PowerPoint's doing the first one, the one on the far left. Normal INV will give you, it goes like this. How about that? Let's jump into it. Equals NORMINV parentheses. The first thing is you're using this exactly as I just wrote it. RAND parentheses, parentheses, no spaces whatsoever, comma. You're telling Excel, pick a random number between 0 and 1, and that's my first number right there. So it allows randomness to take place. Then, after the comma, you're given the cell location wherever the mean is up here. So in this one here is referencing H. Wow, this new computer is not showing the numbers. I got to change the ratio or the whatever, but wherever cell it is, H5, whatever. And there's the standard deviation. So you'd be referring to this cell location right after the mean. Standard deviation cell location. Parentheses. That's it. That's the whole formula. Cell location where the mean is, cell location with standard deviations. Okay? I want to point out something about this uniform, and this rand between. That cell location, I got it backwards. The first one has to be the cell location where the smaller number is. The second one has to be the cell location for the larger. It's different than the other two formulas. It's in small and large. If you flip those, it will keep telling you error. Okay? Now, we got this so far? The last one. You're using an Excel command called VLOOKUP. I'm assuming almost all of you have never seen that before or used it before. And what it's doing, or when you use this, is when you're told, I'll use the mechanic again. The mechanics who work on these planes usually take between 2 and 4 hours. We think there's a 30% probability that it will take 2 hours, and a 35% probability it will take 3 hours. And what's left? Out of 100 here, 65, that's 35, is that right? 35% probability to take 4 hours. Anytime you're told about the data in the form of probabilities, or it says, this could say, we went back through the last 100, and 30 out of 100, it took 2 hours for the mechanic to do it, and 35 out of 100, you may have to turn them into probabilities. But it's literally telling you in some format that you are using these probabilities. Don't let Excel pick the probabilities, or they don't have exactly the same probabilities, but to use the probabilities given. Now here's the weird part when you're given the probabilities. You have to map it. I want to write that word down. Because even if you're given a question on a test, it may say map it. And when you're mapping something, you're converting the probabilities that are given to you into a range of numbers, and the amount of numbers you're using is equal to the probability. Let me jump up here real quick. 2 hours, 30% chance. And I know if I tell Excel to pick a random number, it's going to be somewhere between 0 and 1. Excel uses 0.32, 0.55. I always like to move the decimal in my mind 2 places to the right and say that's 32, that's 55. So for 30 numbers, starting at 0, I'm going to go to 30. There's 30 numbers. If this is Excel, I've got to put a decimal there and put 0.30 instead of 30. I pick up where I left off, 30. And this, now, 3 hours, I'm told it's 35% chance. So I have to use different numbers between 0 and 1 that I've already used, and I have to assign 35 of them to this possibility of 3 hours. So I start at 30, I add 35 numbers to it, I get 65. Because it's Excel, I'm putting a point there, I'm putting a point there. Now I start at 65, and the story says there's a 35% chance it will take 4 hours. So I got to assign 35 numbers, 65 to 100. And you should always start at 0 and always end at 100, and you never need to worry about the overlapping here, because if Excel happens to pick a random number that's exactly between the two, it will figure it out, and you don't have to worry about it. Now I got to change this to decimal. So there, and then 0.65, 1.00. Just move the decimal. So Excel, this is how Excel does it with the decimals. Good.
So we put those numbers in Excel?
No, yes, you are. You're going to create a map. Now look at my map up here. Let me ask you, look at this map. I can see that there might be 43 hours, dollars, whatever is being described here. What percent chance is there that if I were to look at this story, that 43 could be the result? 30% chance. I heard of several people, but not everybody. I want everybody to make sure that you understand where they saw that. They saw that I wrote the numbers 0 to 0.3, which would be 0.30. That's 30 numbers, so I bet the story says there's a 30% chance at 43, whatever that describes. What about 44? What percent chance is that? 40%. You get it now. 30 to 70 is 40 numbers, so the story probably says 40% chance. And 70 to 1, 0.7 to 1, or 70 to 100 would be 30% chance. So there's that. This formula right here that you're about to see goes up to that map, picks a random number, are you ready? 0.47, and tries to figure out where 0.47 lands on the map, and then matches it with the data on the far right and brings it back to the south. 0.47 would bring back what to the south? 44. 0.47 is 47, which is between 30 and 70, so it says, oh, I'll bring back 44. 0.92, it brings back what number? 45. 92 is between 70 and 100. And that's how the math works. Now, how do you write this formula? Use words to describe it in your notes, how this is written. And as long as the words are telling you where to go, when you have to map something, because you're given the probabilities, you then want to simulate that. You're going to use equals. Come on. Switch pens. You guys see that back there? Okay. That's not good. I don't know what's next. You can already hear. Wish the semester was over, don't you? Ready? V, look up. Sloppy lines. V, look up. Parentheses. gotta remember. Oh yeah. R-A-N-D, parenthesis, parenthesis, no spaces, comma. There's the first part. You say in Excel, you pick a random number. Now the second part is telling Excel where to take that random number and match it up where the map's at. Here's the key. You're putting the cell location where the top left-hand corner is, which is where the 0 is at. Then you put colon, and the cell location where the bottom right-hand corner is, where the number to where, well, there's always 3 columns. In this case, it'd be right where that 45 is, not where the number 1 is. But some people put the 43, 44, 45 over here in the first column, then it would be where that 1 is. And the left-hand corner would be the 43 is. Just where the numbers are. That's the point I'm trying to make. Not the title, the word map there. That's not part of the map. It's just describing it. Wherever the numbers are, top left-hand corner, bottom right-hand corner. The cell locations are here. So I go top left, colon, bottom right, comma. The last part of this equation is telling Excel which column, and we almost all have 3, has the information you want Excel to bring back and place in that cell. In this case, it's over here to the far right in the 3rd column, so I'm going to put a comma 3. And for this class, almost every one of them will have it over here in the 3rd column. So this will almost always be a 3. And I'm not going to try to trick you out of a quiz. If you have to do a VLOOKUP, probably.
That's how many there are?
No, that's which column. You're telling Excel which column has the data you want brought back. We want that 43, 44, or 45 to come back, which is in the 3rd column. Okay? Now, here's that VLOOKUP formula. Equals VLOOKUP, R-A-N-D, parenthesis, parenthesis, comma, C7 is where that 0's at, colon, E9 is where that 45's at, comma, 3, because the data we want to come back is in the 3rd column. Look at this uniform. I7 is where the smallest number's at. No, we're doing the opposite one. Where the largest number's at, minus instead of plus. And look at this, the R-A-N-D is after the parentheses. Doesn't matter, because order of operations will multiply whether it's in front or behind it. It's going to multiply first. So I7, the largest number, minus H7, the smallest number, times R-A-N-D, parentheses, parentheses. I want to point out something. On these simulations, dollar signs in front of the cell locations is so important because all the work is in this first line on a real simulation. And then you are copy and pasting 999 cells below it. As long as you did this right, and you're referencing the correct cells, and some of them you want to have dollar signs because you don't want it to change, and some of them you don't have dollar signs because you do want it to change. As long as you have all that, when you copy and paste it 99 cells below it, you can do a quick 1,000 trial simulation, which will answer a ton of questions. Because it simulates every combination of possibility. Go ahead.
For the mapping, will it always start with 0
Always.
and end with 1?
Always. You have to designate 100% of the numbers. Because every time that you're given data with probabilities, the probabilities always average 100%. There's a 100% chance of something happening. One of these. We don't know which one, but we think there's more of a chance of this than that. So we assign some probabilities to it. This one, anything could come up between those two numbers. We have no one better than the other possibility. And this one, we know, I always use Markey as a determinant for this one, because I always hear things like, we know we're going to sell 20,000 of those, plus or minus 5,000. This is how it's always described in a meeting in real life. We know we're going to sell 20,000 of these, plus or minus 5,000. And that's when we got to start figuring out the mean, the standard deviation. They're almost giving you exactly the mean and standard deviation. But then I always have to say, we got to go back to reality. If Markey says 15,000, that means we might sell 13,000, plus or minus. Markey's always the optimistic department at the table. And I love that, which is fine. I'm always the realist. Are you ready? I'm always the downer. Normal I and V, look what's happening here. Parentheses, R-A-N-D, parentheses, parentheses, comma, the cell location where the mean's at, H10, the cell location where the standard deviation is at, I-10. Dollar signs in front of the H and the 10, the I and the 10, because when I copy and paste, every one of these, I want to always look at H10 and I10. I don't want those cell locations to change. But let's say I'm having it look up there, but I wanted to multiply the cell before it. The reference to this cell would not have dollar signs because even though I always wanted to look up there, I put dollar signs, but when I copy and paste it, I want this one to be D19, then I want it to be D20, then I want it to be D21. So I want it to change. That's when you leave the dollar signs off, when you want that to happen. Let's talk about this spreadsheet as an example that I posted. So you can kind of see how these work. This is a great example because it's showing you all three types of simulations that we're learning in this class. Right up here, the story might say, hey, we're thinking about expanding our business into this new product. We think it's going to sell for we're planning on it selling for $249 a piece. That makes us competitive. We think we're right there with the quality of this item where we want to jump into the market. We make golf items now. We want to expand into golf bags, and we're going to sell these golf bags at $249. I'm just hypothetically throwing something out. The administrative overhead is going to be $400,000 no matter how many we make if we go into this. And our advertising cost that we're planning on is $600,000. That overhead is there no matter how many we sell. So those are fixed costs. Then in the meeting, if someone said in production, hey, I know labor for every one of these golf bags we make, hypothetically golf bags, it's going to be somewhere between $43 and $47. You know, I've almost got it worked out. Looks like it's going to be about what % chance does the story say it will be $43 for labor? What percent? 10%. 10%. What % chance of $44 per hour or per item? 20% chance. 45 would be 40% chance, 30 to 70. 46 would be a 20% chance, 70 to 90, and 47 has about a 10% chance. You're reading the story, you are coming up with the math numbers based on those probabilities you were given. And the person next to you wants to start with 47 at 0, that's fine, as long as you're only using 10 numbers, because 47, the story says, 10% chance. You don't have to start with 43 to 0, as long as the numbers you assign equal the probability given in the story. All right? So,
do we have to go in order? So like, could we do like
no,
40?
That's
could we
all
do 0.0, 0.1, and then the next line 0.3, 0.7?
yeah, as long as you're not crossing numbers in the ranges. So you're saying 0 to 7 up here,
Yeah.
which is 40 numbers, so 45 would be here, or 44 or something like that, that's fine. No problem, it will still be fine. The point is that you're assigning the exact same amount of numbers as the story tells you the probability is. That's the key. It literally gives Excel a 40% chance of that being the cost of living. Because every time it picks a random number, these are the exact probabilities it will assign as it picks the number. Or the probability of that number matches. All right, the story keeps going. Manufacturing at this meeting said, and we figured out exactly what the parts will cost approximately. We've talked to our suppliers. We've got good ranges of what the prices will be for the raw materials. And we know for every one of these golf bags, $80 to $100 on materials, on parts and materials. So, and then you say, hey, is it closer to 100? Is it closer to 80? We think there's an even chance it could be anywhere between 80 and 100. And so you're writing notes uniformly distributed. Same exact probability. Here, in yours, it will say uniformly distributed. In real life, we think it's the exact same probability. We cannot say there's more of a chance of 180 until we get more information from our suppliers or whatever the case may be. Then, marketing said, we're selling, it's just a coincidence, I did not know, remember that was 15,000. We're going to sell 15,000 of these plus or minus 4,500, and you know, and you get some information to try to figure out where they came up with this, and you say, okay, you know, you do a little math or whatever, you say, yeah, we'll go with 15,000 plus or minus, meaning one standard deviation, about 4,500. So here's normal, here's uniform, here's we know the probability chances of this cost of labor. And now the question says, you calculate the profit or loss, and simulate the things that we don't know for sure what could be. And as long as you do enough trials, every one of these lines would be a trial. And as long as you do enough of them, every possible situation will be demonstrated somewhere in those trials. And for example, labor, in one of these trials, labor is the best you could dream of, the lowest at $43 per item. And cost of parts, oh my God, look at that. It ended up being $80 an item, the lowest there. And demand, oh my gosh, demand is significantly over $15,000. I call this the perfect situation. Your costs are as low as possible, your demand's at the higher end, you're gonna make money. All right? This is a good example because it's not at the lower end, but more than that. But this also simulates what I call the perfect storm. Oh my God, I can't believe labor came in at 47 after all that stuff we tried to figure out. Oh, I can't believe parts came in at 100, almost $100, the highest it could have been. And demand, we didn't even come close to 15,000. We're only at about 11,000 in demand. You're gonna lose money. And this simulates every one of those situations. Good labor, mediocre parts, high demand. I mean, every combination you can think of, you simulate based on these meetings. And then, at the end, you start working an analysis. You're going to take this column right here, and you want to know what's the largest amount of profit we could experience? What's the largest loss we could experience? Out of 1,000, how many times is this simulation telling us we could experience a loss? Oh, there's 40 of them? Well, what's 40 divided by 1,000? Because that simulation is trying to tell us, here's your percent chance of going forward with that $2 million and losing. That's what a simulation does. It helps bring everybody's mind to reality and says, look, based on all this information we all put together as to the probability for labor and parts and demand, there's it will tell you, and it could be, if it says like 12% chance of a loss, we don't want to risk. You got to treat this $2 million like, I know it's the company's money, but you got to treat it like it's your own. Would you put $2 million on the line knowing you have a 12% chance of losing? So that's where then it steers our meetings into what can we do to get this cost down, to make our chances of losing money lower. The goal I used to always say is 5% or less. If we're going to risk this much money, we want a simulation that's going to say to us, you have less than 5% chance of losing money based on this information. When you get to that point, it's when you go, let's spend the $2 million. Let's do it. 95% chance of making money. Let's do it. Let's roll the dice. That's what this does for you. That's one of the biggest things you calculate. What you see, what the most you can make. That usually takes everybody to go, oh, look at that. On this $2 million investment we can make. I don't know how much the investment is on a simulation, and I don't know at the end here. Do we have some numbers? We could make $2,378,000. Yes, let's look at the largest loss. We could lose $866,909 in the first year. You got to look at both those. How many losses out of how many trials? 500 trials, 43 losses was turned into a probability. 8.6% chance, 0.086. This is where the debate goes on, right here, because that's right there between the 10 and the 5, where people go, oh, yes, no, yes, no. Now, if you go back to your suppliers up there, and you say, look at what we were able to get from our suppliers. Our parts of materials and parts is now not between 80 and 100, but between 75 and 95. And by using cell locations, you just go here and switch that to 75 and 95 and watch what happens. Matter of fact, you want to do that one? Let's do it. What was our percent of losing money? I forgot. 7.9? 8 point what? 6. Okay, here we go. Let's see what happens. We got the suppliers to where we can narrow it down to $5 less on both ends. I want to make sure. Look at it. Also, people freak out at this. As you're working on a simulation, you have one coming for your homework. It will be assigned Wednesday through Monday. By the way, it's going to be the hardest homework assignment you've had, but you're going to be okay. Because I'm setting aside time this weekend for your emails to help you. All we did was change these two numbers, and and we're going to see how it affects the whole thing. As you're working on this, every time you click return on anything, all the numbers change, and that's normal. Don't let it freak you out. Every time you open this, the numbers change. That's what simulation does. It's constantly changing the numbers.
So if you hit,
And you want to run this, 10 times and watch the numbers.
so if you hit enter right now, it would change again?
Everything. Watch. See it all change? You see the numbers changing? But that's not so important. It's the numbers down here that you want to stare at when I do that.
Wouldn't those numbers change too?
Exactly. That's right. But they're still, you watch this 10 times. Is it ever below 5%? That's the question. You ready? There's one, which is 7.8. What's going on? Why is that not changing? And yeah, that can't be 7.8 every time. That's too unbelievable, actually. Let's watch what happens. There we go. 9.8, 8.4, 6.8, 7.6. It's obviously almost always above 5%. Which, oh wait, this is after we changed the numbers, isn't it? Gosh. So we're still. Okay, let's go talk to the union about labor. Let's see what we can do. All right? Because we still aren't there. Our risk on us investing this $2 million is still way too high. Not way too high, but I'm not willing to do it. If this were real money, no way. I mean, when I say real, my own, no way. Even the company's money. Why would we want to risk that much without a really good chance? And this is how you get people to focus on what can we do? Oh, labor. We were able to get that. The union agreed that a certain part of this could be done automatically. They're okay with that. We've taken a little part out of it. Now our labor cost per item is going down $1 at each level. Again, this is kind of like your Excel spreadsheet for your grade. You're just testing out different numbers. And here we go to 5%, 6.6, 8, 10, 6.6, 6.6, 8.4. So we're still aren't there. Even though we renegotiate labor, we renegotiate with our suppliers, it's still a lot of risk. We still got to do either a little more negotiation, or we got to drop this and look for some other way to invest this money.
In the real world, when you're doing this and you're doing proposals for projects, what's the minimum number of trials you use?
1,000.
1,000.
1,000. I always use 1,000. I wanted the trials to resemble anything that could happen in real life, and that's what the simulation does. Every combination you can think of that's good and bad. If we went through here, that loss right there, that's like the perfect storm where it was simulating labor high, materials high, and demand low. That perfect storm caused that kind of a loss. And in real life, you have that possibility. And it's devastating. When you, let's say you've taken a significant amount of your savings to invest in this, and you lose that much in the first year, it could literally put you out of business because it's going to strap you. That cash, that lost cash had to come from somewhere, and it's probably me at the bank trying to negotiate an emergency line of credit to cover this because we got payroll. All right, that's it. Just looking. Boy, that 10's scary, isn't it? This is how simulations work. Now, let's go to the PowerPoint. Now, I want some participation here. You're going to talk me through this. This company that does investing said, they were looking at their stock, and they said, we're going to look at the last 50 trades of our stock, and we want to see how much change in the price of our per share has taken place. And the changes in price are 3/8 of a dollar, 1/4, 1/8, 1/8. Changes the cents if you want. Whatever 3 divided by 8 is, 30. What is that? 37.5 cents or something. 12.5 cents. Is that right? Cents? Are we talking about cents here? Yeah. Half would be a half a dollar, 50 cents. So we're given this information, and right now you should be able to say, oh, this is like we're using the past to predict the future, and we got to turn this information into probabilities. And notice, look at how many times there was no change in the price of our stock, and out of 50, what's 20 divided by 50? That means if we're using historical information as our guide, we're going to give a 40% chance that the next trade will have no change in price. 10 divided by 50, so that's what, 20% chance? We are given based on the past, we're going to assign 20% that the price will change 1/8 of the dollar. And so you take each of these and divide by 50. I probably, on a final, would not give you the information that way and have you have to do all that work to turn them into probabilities, because that would take too much time. What I want to see is if you can take the probabilities and map it, which shouldn't be hard, but I thought a forward pass wasn't going to be hard. So I got to make sure you're getting this, all right? So we turned it into probabilities, which add up to 100%. And now we're going to map it starting at the number 0. According to the last 50 trades, there's an 8% chance, so we'll use the numbers 0 through 8. A 4% chance that it will go 25 cents down, so we'll assign 4 numbers, 8 to 12. 16% chance we'll assign. Now if this is Excel, that's 0.0, 0.08, 0.08, 0.12, 0.12, 0.28. Does everybody get it? That's the difference between this and Excel. It's just where the point's at. 28 through 68, and so on and so on. I mean, at 100. Now you use a VLOOKUP command, and I got to pick a random number. 21 comes up. The price of the stock right now is at $23. So our stock right now is at $23. And the random number comes up 21. Is that what it is? Look at your PowerPoint. Is it 21, you guys? Anybody? No one has the PowerPoint. We are recording? You read all this before you got here. 21. And you look at the map you made, and 0.21 or 21 lines up between two numbers, which means the price would be doing what? Being what? Decreasing by 1/8. Minus 1/8. The next random number is this, and if this were a quiz question to say, here's 5 random numbers, the price starts at $22 or whatever it's at, $23. What will be the price at the end of 5 trades based on the random number? In this example, it starts at $23, but there's 10 trades. But a quiz question, we don't have time for 10 of them. Let's just do 5 or 3. So 21 matches up with going down an 8. So now we're at the price of $27, $22. And by the way, it won't say an 8, we'll say 13 cents. So now we're at $22.70 whatever cents, 77 cents. 84, you look at the map, oh, that says it's going up an 8. So now we're back to $23. The next number, 7, oh, you look at the map, that lands between here, we're going down 3/8. Have I lost anybody? I mean, this almost seems like I'm boring you, right? Are we okay? Everybody get it? And at the end of 10 trades, the price of that stock ends at $23.13, whatever what it is.
So for like the 10 trades, that would be you doing 10 simulations, right?
Yeah, you're doing 10 trials. Instead of telling Excel to pick the random number, you're given the random number, and you're telling me what Excel will result in. You get it? Okay. Let's try another one. Here's using Excel to do it. Blah, blah, blah. All right. You ready? He is trying to predict the repairs in the future, what city this plumber will have to drive to. And his repairs are in 3 cities. What are they? They're Austin, San Antonio, and Houston. Now, if this is a problem on the quiz, the story where he goes and looks at the last blankety blank number of days to see what city he was in and what city he went to the next day. But in this case, I would literally give you the probabilities. So I'm going to skip this and go right to here. It will say, the plumber looked, every time he was in Austin for the last year, 60% of the time the next day he still had to stay in Austin. 15% he went to San Antonio, and 25% he went to Houston. That adds up to 100%. So if I said to you today, hey, you're in Austin, and you map this, and the random number came up 0.02, most likely, where will you be tomorrow, according to the simulation? Where? If you're in Austin today, 0.02, think about how you mapped Austin. Where would the number 2 land? What city would you be in tomorrow? Okay, you guys, let's work on this map. Austin. All right? Austin. If you're in Austin today, and you're going to be in Austin tomorrow, the map goes from 0 to what number? What percent chance? 60. okay, or 0.0 to 0.60. Start at 0.60. If you're going to be in San Antonio tomorrow, the odds are 15. Does that say 15? 15%. 60 to what? 75. Or 0.75. Start at 75 now. The last one's going to take you to 100, which is 25 numbers, right? 0.02. If you're in Austin today, most likely you will be where tomorrow? Austin. You get it. All right. Now look at San Antonio. It also adds up to 100% chance. The plumber looked back at any of the days from last year that he was in San Antonio and counted how many times he was in one of these three cities the next day, and then turned it into probabilities. 20%, 75%, 5%. Think about it, ready? I'm in San Antonio today, 0.25. Where am I most likely going to be tomorrow? You got it. Now, for those who didn't get it, they visualized that 0 through 20 would probably be the first 20 numbers. And at 0.25, the next numbers would be 0.20 to 0.95? Is that right? 0.95, which 0.25 landed between, so that's why they said San Antonio. And then the last one would be 0.95 to 100, 0.95 to 1.0. Here's Houston now. Houston, if we're in Houston today, 15% chance, Austin, 5%, and 80%. And my question for you is, if we're in Houston today and the random number came up 0.98, where are we most likely tomorrow? You got it. They visualized the map here, 0 to 15, 15 to 20, 20 to 100, 0.95 I said, or 0.98 is in between the 20 to 100, so that's why Houston was the answer there. And sure enough, that's exactly what's happening on this PowerPoint. Here's the map if you're in Austin today. Here's the map if you're in San Antonio. Here's the map if you're in Houston today. Now you're looking at the map you created, and it says, today you're in San Antonio, 10 is the random number. Where are you tomorrow? Austin. Went to the San Antonio map, matched the 10 up, there's where you're at. So now you're in Austin, and the random number 32 comes up. Where are you at tomorrow? You get it. You went to the Austin one. Now, what you're doing in your mind and what we're describing, you've got to get ready to be able to write that out using the Excel function. So I posted this Excel help. Whoops, where'd it go? Just got to find it. This Excel help right here with all the different functions so you can remind yourself how to use them. But the ones most people need to focus on are this if statement right here, count if, max and min, where's the other one? RAND, we learned the uniform formula, the normal IND formula. So this is all posted for you. And this is where I want to pick up on Wednesday, going over especially these, because there's a lot of people who may have never used these. This section, this chapter, is not only about writing simulations using one of these three, but it's about writing the simulation to logically come up with whatever it is you're trying to find. That example I showed you, the story said, simulate the profit. Where is it? Right there. You can move up. Based on what our revenue might be, I mean, this right here, this is the cell. These cells that I just taught you were easy. You're either there's a map, or there's a small or large value, or there's a mean standard deviation, so you know which one of these three to use. This is from accounting. And so the old accounting thing is profit or loss is always revenue minus expenses. And this has to be in cell locations. So this is the part you've got to also focus on, because this is where people start to lose points, because I just made this part easy. This is going to be our demand times our selling price minus our fixed cost of 400 minus our fixed cost of 600 minus demand times our cost of labor per item minus our demand times our cost per unit for parts and material. That's what's left. Right? Did I cover everything? Fixed cost, variable costs, revenue. And you've got to use cell locations. So in parentheses where you're multiplying so the order of operations takes place correctly. All right? That's where we're heading. Wednesday, I'm going to put it, I have an assignment for you, I'll post it, and it's going to be making a simulation kind of like this, where you're going to have to show me, you can write these cells, and you've got to come up with that ending one. I'm going to be asking you for profit or loss. But you also, down here, look at this. How are the number of losses found? That's where that count if comes in. So you see, this one use count if. Equals count if. It's looking through this whole E column. And there's the question at the end. Count all the numbers in this column, and then in parentheses or in quotations it says any of them that are less than 0. 33 of them in this simulation out of 500 is 0. And that's usually how you use count if. That's the parts that's kind of the hardest from this chapter are these things. So that's what you want to kind of focus on a little bit too. All right, that's what we'll pick up on Wednesday. Thank you.